Welcome to Topic Wise. Today's topic is ray diagrams for image formation by concave mirror. Concave mirror is a spherical mirror whose outer surface is polished and inner surface is the reflecting surface. Reflected rays intersect or converge when light rays fall on a concave mirror. So that concave mirror also called as the converging mirror. Concave mirror gives different types of images when object is at different places in front of the mirror. Now we draw ray diagrams. Ray diagrams are useful to know the details of the image formed. So here to draw the ray diagrams I am using one compass and take a scale, and now I am taking 5 centimeters of length. By using this 5 centimeters of length, draw one arc. This is arc whose radius is of 5 centimeters, and now shade the outer surface. Now this mirror is a concave mirror and this is the midpoint P. Now join this midpoint P and the center, and this is the center of curvature. This PC is the radius of curvature and midpoint at 2.5 centimeters. This midpoint is the focus. This PF is the focal length. Now draw two lines which are parallel to the principal axis, and these two are the two lines which are parallel to the principal axis. Strike the mirror at two different points A and B. Suppose this is the first incident ray coming from the object which is at the infinity, and this is the second incident ray, and this is the third incident ray which is coming from the object and passing through the radius of curvature or principal axis. Now from the definition of the focus, the line which is parallel to the principal axis, that ray after reflection passes through the focus. So this is the first reflected ray, and this is also parallel to the principal axis, so that this ray also passes through the focus, and this third ray which is passing through the principal axis, when it strikes at point P pole, then it retraces its path. Now these three reflected rays actually met or intersect or converge at one point by forming the real image. So at point F, real image forms, and real images are the usually inverted images. So this image is the inverted image, and when you see its size, it is very small image, almost point size image. Now based on this concept, now question and answers. First question, mention the nature of image formed by the concave mirror when object is at infinity. Answer is, the object is at infinity, hence image will form at F focus. Nature of image is, it is a real image, inverted image and very small, almost point size. Second question, a light ray travelling parallel to the principal axis falls on a concave mirror. What is the path of the reflected ray? Answer is, reflected ray passes through the focus F. Third question, what is the real image? Our answer is, if two or more light rays after reflection or refraction actually meet at a point, the image formed is a real image. Real images are inverted with respect to the object and they can be caught on the screen. Fourth question, draw ray diagram for formation of image by a concave mirror when object is at infinity. This ray diagram is our answer for this question. And next question is, complete the following ray diagram. Here what is given? One mirror, one spherical mirror, and its midpoint P is given, and incident ray is falling on the inner surface of the mirror. So this is one concave mirror. So first you draw, for the answer, draw the concave mirror, that is polish it outer surface, and this M dash is the mirror This is the midpoint, and draw one radius of curvature. This is the principal axis, and our ray is parallel to the principal axis. Draw the incident ray, put one arrow. Now this is the focus. The ray which is parallel to the principal axis always passes through the focus. So this is our reflected ray, and now draw one normal also which joins the point of intersection, point of incidence and the center. So this is the answer. Now we draw the ray diagram to obtain the image when object is between infinity and C, that is behind C. This is one concave mirror whose radius of curvature is of 5 centimeters. By taking the 5 centimeters, draw one arc. This is concave mirror, so outer surface is silvered, and at center, this is center of curvature at 2.5 centimeters. This is of the F focus. Now this is one object AB whose height is of 1 centimeter. When object is at a measurable distance, then take two rays originating from the same point but with the different directions. Draw two incident rays which are originating from the same point of the object but draw them in different directions. Now one ray is parallel to the principal axis and another ray is passing through the focus. The ray which is parallel to the principal axis after reflection passes through the focus. So this is the direction of the reflected ray, and the ray which is passing through the focus after reflection passes parallel to the principal axis. So this is the direction of second incident ray, and this is the point where the two reflected rays intersect or converge. At that point we obtain one image. This is the image, and this is the point where the reflected rays which are coming from the A intersected. So this point is the image of the point A, and the ray which is passing from the B retraces its path because it is passing through the principal axis. So this is the point, that is reflected ray of the point B of object. So here we get the image of the point B. So this A dash B dash is the image of the AB, and this is one inverted image of this erect object. And you see the size of the image. Object size is of 1 centimeter, but image size is of just half centimeter. So this is one small image. So when object is between infinity and C, image is between C and F, and its size is diminished or small, and the nature of image is it is a real image because it formed by the actual intersection of the reflected rays, and it is one inverted image. On this concept, our questions are: a light ray is traveling through the focus, falls on a concave mirror. What is the path of the reflected ray? Our answer is reflected ray passes parallel to the principal axis. Which mirror can make a parallel beam of light when light from a point source incident on it? And we know that if the ray is passing from the focus, then reflected rays pass parallel to the principal axis. To obtain the parallel beam, we had to keep the source at focus. So our answer is when light rays from a point source are incident on a concave mirror, they reflect to form a parallel rays provided source is placed at the focus. Next question. Write the details of image formed by concave mirror when object is behind C. Answer is object is placed behind C, hence image will form between F and C. Nature is it's a real, inverted and small. Next question. The radius of curvature of a concave mirror is 6 centimeters. R is equals to 6 centimeters. And draw a ray diagram of an object of principal axis at 8 centimeters from the pole. So this is 6 centimeters distance, but our object is kept at the 8 centimeters. So that is behind C. So when object is behind C, then this is the ray diagram for our answer. Now our object is at C, that is on center of curvature of a concave mirror. Now let the object is a candle which is kept on center of curvature and whose height is of 1 centimeter in our diagram. This is 1 centimeter length candle and this is AB. Now take two rays from point A, which is top of the candle, that is from the flame. So this is one ray from the flame and A, and this is another ray which is passing through the focus. And now this ray which is parallel to the principal axis, after reflection passes through the focus. So it passes through the focus, and this is the ray which is coming from the point B, that is the bottom of the candle, and after reflection it retraces its path. The ray which is passing from the principal axis or the ray which is passing from the center of curvature, they retrace their path. Such incidence is known as the normal incidence. The ray passes from the normal. So this is normal incidence, so that this ray retraces its path. And now this is the ray which is coming from the focus. The ray which comes from the focus, after reflection it passes parallel to the principal axis. This is the direction of the reflected ray. And now where these reflected rays meet, at that point we obtain one image. This is the image, and in this image this point is the image point of the rays which are coming from the top of the candle. So this image of the candle top appears at this point and bottom appears at this point. That is one inverted image, and this image has formed by the actual intersection of the rays. So this is one real image, and size of the image is equals to, this is a 1 centimeter object and this is 1 centimeter image. So size of the image is equals to the size of object. So when object is at C, then image position is at C and size is equal to the object size, and nature is it's a real and inverted image. Some question answers. Give an example of normal incidence. An incident ray which passes along the principal axis or through the C reflects back in the same path. Such incidence is the normal incidence. Second question. An object is placed at the center of curvature of a concave mirror. The distance between its image and pole is, object is kept on the center of curvature. Then what is the distance between the image and pole? That is equals to the 2f or r. That is equal to r or 2f is our answer. Next question. In concave mirror, the minimum distance between real object and its real images. This is one real object AB is, and this is one real image formed by the actual intersection of the rays. So that distance between these two is 0. So that our answer is 0. And next question is, where do we keep an object of 5 centimeter height in front of a concave mirror to obtain the image of 5 centimeters? Here in our question, object size is equals to image size. So when do we get the equal size image? When object is kept at C. So our answer is at C, that is at center of curvature. And next question, mention the nature of image formed by concave mirror when object is at C. Nature of image is, its location is at C and its size is equal to the object size, and it is a real and inverted image. And next question, complete the ray diagram. They will give the diagram, such diagram, and we have to complete the ray diagram. Now keep the object between C and F. Here our object is between center of curvature and focus. As usually, take one object which is of 1 centimeter height, and object is kept upright to the principal axis. So this is one erect object AB, and now from point A draw two incident rays which are directed in two different directions as usual. One is parallel to the principal axis, and another ray is passing through the focus, and one ray which is from bottom of the object passes through the principal axis. This is ray 1, and this is second ray, and this is third ray. And we know the ray which is parallel to the principal axis after reflection passes through the focus. So this is the first ray, reflected ray of first incident ray, and this is second reflected ray, and this is third reflected ray. These rays meet at one point. This is the point of intersection of the reflected rays. Here we obtain one image, and this is A dash, B dash, and this is one inverted image, and this is of one real image because of actual intersection of the reflected rays. So this real image can be caught on the screen. When we see the size of the image, object size is 1 centimeter, but image size is 1.5 centimeter. That is, image is larger than the object. That is, we obtain one large size image here. And when object is between C and F, image is formed between C and infinity, that is behind C, away from the C, and it is one enlarged image, that is large size image, and its nature is real, which can be caught on the screen, and it is one inverted image which is below the principal axis. Now come to the questions. First question, where is the base of the object to be in the image when object is placed on the axis of the mirror? This is base. Our answer is any ray starting from point on the axis and traveling along the axis will get reflected on the axis itself. So the base of the image is going to be on the principal axis. Base will be on the principal axis. Second question, when does reflected ray in same path from a concave mirror? When incident ray passes through the center of curvature, when incident ray passes through the center of curvature, then its path is in the same direction. Next question. Draw a ray diagram for which an enlarged real and inverted image is formed by concave mirror. Here conditions is image must be enlarged and it is real and inverted. So this is the case. Our answer is an enlarged real and inverted image by a concave mirror is formed when object is between focus and center of curvature. And for this ray diagram is this one. This is the ray diagram. And when you observe one thing, when object is moving towards the concave mirror, then image moves away from the mirror. First it is on focus and next it goes away from the focus. When object is on C, it will form on C. When object is between C and F, the image forms away from the C, and as the object comes towards the mirror, and size of the image also increases. Now object is at focus. So this is object on focus AB. Draw one incident ray as usually parallel to the principal axis, and another incident ray is directed towards the C, center of curvature. This is another incident ray. These are two incident rays, and which is parallel to the principal axis after reflection passes through the focus, and this is the direction of second incident ray, and which is directed towards the center. It passes through the center, retraces its path. These two are two parallel rays. They cannot meet, so that they cannot form image. Image may form at infinity. So when object is at focus, then image forms at infinity. Now come to the another ray diagram. Here object is between pole and center of curvature. Sorry, it is between pole and focus, and one is directed parallel to the principal axis, and another is directed towards the center of curvature. This is second ray, which is parallel to the principal axis after reflection passes through the focus. This is the reflected ray of the first incident ray, and which is directed in the center of curvature direction. It retraces its path. So these rays cannot meet in front of the mirror. So to obtain one image, just extend back the reflected rays, and here we extended the reflected rays back. When these reflected rays extended back, then they meet at one point. At that point where the extended rays intersect, at that point we obtain one image, but that is one virtual and erect image. So when object is between focus and pole, then image forms behind the mirror, and it is one virtual image because of the it has formed by the extended reflected rays. And virtual images are generally erect images. So this is one erect image, and it is enlarged image, and object size is of 1 centimeter, but here image size is of 2 centimeters. Our questions are: do we get an image when object is placed at focus of a concave mirror? Draw the ray diagram. Our answer is: when an object is placed at F, we cannot get an image on the screen. It will be formed at infinity. Second question: name the mirror that can give erect enlarged image. A concave mirror can give erect and enlarged image when object is between focus and pole. Third question: A student wants to obtain an erect image of an object using a concave mirror of focal length 10 centimeters. What will be the distance of the object from the mirror? To obtain the enlarged and erect image, we have to keep the object between F and P so that its length should be below the 10 centimeters. So our answer is less than 10 centimeters from the pole of a concave mirror. Fourth question, where should the object kept in front of a concave mirror to get virtual image? Draw the ray diagram. Answer is when object is kept between the pole and focus of a concave mirror, then virtual image is formed in the inside the mirror. And the ray diagram is, this is the ray diagram. Thank you for watching.